Let's proceed to next subtopic, photon and electromagnetic wave. Right. Light has a dual nature. Okay. It exhibit both wave and particle characteristic. Applies to all electromagnetic radiation, is not only actually for electron. Different frequencies allow one or the other characteristic to be more easily observed. Okay, so most of the time we cannot observe both of the characteristic at the same time, right? It's only will experience or show the behavior as particle or wave at any instant. Alright, okay. Then the photoelectric effect and Compton scattering offer evidence for the particle nature of lights. Okay. When the lights and matter interact, light behave as it is were composed of particles. Okay. Interference and diffraction offer evidence of the wave nature of lights. Okay. So, for example, for electron, if we observe it, we refer to the situation where it behaves as particle. Where what is particle? The energy is in corpuscle or tiny packet. Okay, in a packets of energy. Okay, so we can observe the electron in clear image. However, when we do some experiment and it behave as a wave, then the image of the electron most of the time will be slightly blurry. Right? Let's take a look on another subtopic where we have a dual nature of lights. Okay, so what does that mean by dual nature of lights? Okay, light is a wave as well as particle, isn't it? As a wave and as a particle, both of it correct. Okay, however, in classical physics previously, the electron, for example, okay, is treated as particle. Okay, just now, okay, we learned that particle also can behave as a wave. Okay, the person that in charge of proving this one is Louis de Broglie. Okay, he discovered that the wave nature of electrons, because previously electron treated as particle, and Louis de Broglie awarded Nobel Prize in 1929. Okay, for this idea. Right. So let's have recall of the phenomenon in physics. Okay, so reflection. Okay, for reflection, okay, the light can be explained in terms of wave. Yes, agreed by classical physics. Okay, for reflection of lights, okay, also can be explained in terms of particle. Okay, and then it just like imagine you are as the light. When you go to a boundary, you bounce back from the boundary, right? So let's say this is a wall. Okay, so if it is a ball is thrown to the wall, what will happen? The ball going to be reflected back, right? So same goes to the electron. If the electron is incident on the surface, it can be reflected. So this is what we call it. Why is it phenomenon of reflection also can be explained in terms of particle. For refraction, bending process, okay, can be explained in terms of wave as well as in terms of particle for lights. Okay, for interference, okay, it can be explained well in terms of wave. However, it cannot be explained. Classical physics cannot explain why particle, okay, can have interference pattern as well. For this one, we are going to go in detail for electron that are going to exhibit interference. Right? Diffraction, of course, by classical physics, light can behave as a wave and can experience diffraction process. However, again, for particle, it cannot be explained, okay, in terms of particles. Okay, polarization also the same, can be explained in terms of wave, but cannot be explained in terms of particle by using classical physics. Alright, for photoelectric effect, okay, by using theory of wave, okay, it cannot explain what is happening in the photoelectric effect, okay, when the light treated as wave. However, when the light is treated as particle, it can be explained well, okay, by quantum or modern physics. Okay. Wave properties of particle. In 1924, Louis de Broglie postulated that because photon can have wave and particle characteristic, perhaps all forms of matter have both properties. Means that we, as a particle, also can have properties or characteristic of wave. Goes the same to the baseball, netball, bowling ball. Okay. Furthermore, the frequency and the wavelength of the matter wave can be determined. How to determine it? By this. Okay. De Broglie wavelength and frequency. The de Broglie wavelength of particle, based on the theory of de Broglie, it says that the wavelength of a particle that exhibit behavior of wave, okay, is equivalent to Planck constant divided by momentum. Alright, means that the object only can experience or having of characteristic of wave whenever, okay, it is in motion, because momentum is actually multiplication of mass and velocity. Okay, not to forget that at any time or instance, the frequency of wave, okay, matter, the frequency of matter wave is F, equivalent to E, the energy of the photon, over the Planck constant. So from here, okay, the dual nature of the matter, okay, the de Broglie equation show the dual nature of the matter. Each contains matter concepts, energy and momentum. Each contains wave concept as well, where it has wavelength and frequency. So this is the relationship. This is in terms of wave. This is in terms of wave, where we have lambda. This is in terms of particle, where we have momentum. Right? So please take a look on question number 30, page 884. Okay, the question itself, an electron and a 6 kilogram bowling ball each have of 4.5 eV of kinetic energy. Okay, calculate A, the lambda of the electron, and B, the lambda of the bowling ball. Okay, and C, calculate the wavelength, okay, of the photon. Okay, given the energy of it is 4.5 eV. Not to forget that we need to convert the unit of 4.5 eV here to the unit of joule firstly. Alright. Then we are going to use kinetic energy to find each particle speed, or realize that kinetic energy is equivalent to, okay, momentum squared divided by 2m. To rewrite the de Broglie wavelength as, okay, why is it so? Okay, so first thing first, you need to convert, okay, 4.5 eV is actually equivalent to 7.2 times 10 to the power of negative 19 joules, right? And then we know that kinetic energy is equivalent to half mv squared, right? P squared so if we would like to have P within to replace the mv term in the KE formula, so m half in the front, v squared everything over m, right? Okay, so this is in terms of half p squared over m, right? And then the lambda is equivalent to h over p, where our p just now, momentum just now, right? This is KE. So KE, so if you would like to have P only, P squared equivalent to 2 KE, right? Times with the mass, right? If it is only P, square root of 2m KE. Okay, then we're going to substitute it here. Momentum is equivalent to square root of 2m kinetic energy. Right. So, to answer the de Broglie wavelength, lambda here is equivalent to 6.63 times 10 to the power of negative 34 over square. And the mass of the electron, we should know this, 9.11 times 10 to the power of negative 31. Okay, times with the kinetic energy just now, which is this one. Okay, 7.2 times 10 to the power of negative 19. Right. Where it gives you, okay, 5.79 times 10 to the power of negative 10 meter. Okay, so settle for A. Right. Then now, Madam going to proceed for part B. B, lambda for bowling ball. This is bowling ball. Is equivalent to, again, you're going to repeat this, h over square root 2 times the mass is 6 kilo. The energy, the kinetic energy, 7.2, 10 to the power of negative 19, square root of everything. Okay, it's equivalent to 2.26 times 10 to the power of negative 25 meter. Okay, so this is the wavelength for bowling ball. Okay, if you refer to this, if you analyze this value, this one, lambda of the electron, okay, is this amount, and lambda for bowling ball is this amount, power of negative 25. It's too small compared to the lambda of the electron. That is why the electron can exhibit, okay, interference pattern, okay, but not the bowling ball. Okay, this is bowling ball 6 kilo, isn't it? Why is it? To have interference pattern, the wavelength of the material or lights, okay, must be at least equals to the separation distance between the plates, if you still remember, right? So let's say this is our, if you still remember the Young double slit experiment, right? This is a slit, single slit, and then you have double slit, and then you have your screen over here. All right, on your screen is going to be, okay, bright area alternating with the dark area, isn't it? And the dark area, so in between them you're going to have dark. Isn't it? So what is happening actually, the size of the slit here, okay, the opening, okay, the D, okay, the lambda, okay, that passing through the wavefront, okay, that going to pass through this and then exhibit here, overlapping, isn't it? If you still remember, okay, and so on. So the lambda here at least bigger than or equals to the D, the opening. You just imagine yourself. If you want to go through an entrance, if the entrance is just slightly equals to your size, then you will have a trouble, isn't it? And then you're going to somehow narrow, somehow adjust the position of your body. Same goes to the wave. Okay, so at least must be equals to, okay, or bigger than. If it is bigger, if you are bigger, your size is bigger than the door, what will happen? For sure you are going to adjust the way you move, isn't it? The adjustment going to cause interference. Okay, so if you see here, it's 10 to the power of negative 10. Normally we do have, okay, material within this size, because the size of an atom is in terms of negative 15 meter. But if you have negative 25, okay, you have no material that's smaller than this one, because this is too small already. That is why we cannot see the behavior interference pattern when you have bowling ball moving, okay, through a door, let's say. If bowling ball cannot show or display the behavior or proof as a wave, okay, theoretically it can have wavelength, but then as of now, okay, it cannot show the behavior as the interference pattern, perhaps, okay, because we do not have the material smaller than this. Okay, right, and this is answering for part B. Now let's proceed to part C. Okay, in part C, okay, calculate the wavelength, okay, lambda P of a 4.5 eV photon. This is part C. Okay, lambda of the proton equivalent to Hc over the energy, okay, it has, okay, equivalent to 6.63 times 10 to the power of negative 34, okay, times with 3 10 to the power of 8, the C, over the energy just now, 7.2 times 10 to the power of negative 19. Therefore, the lambda will be 2.76 times 10 to the power of negative 7 meter. Right. So, even proton, for proton, is order of negative 7. So, means that it can display interference pattern, or it can exhibit this kind of phenomenon. Right? Because the D, the separation distance between the slates, can be done within this. Normally nano, micro, right? Okay. So, I'm talking about just now electron diffraction indirectly. So, if you still remember Young double slit experiment, okay, where we have light source is incident on two slits, okay, where it's going to be diffraction, right? And then they are going to overlap. Seems like they have two source, monochromatic wavelength, two coherent source, and then they're going to overlap and producing the middle one is bright area, okay, bright area, dark area, alternating up and down. Okay, so the image display on the screen actually in terms of this, because we are using electron. Okay, so the wave particle duality, since we are using electron, we are expecting this is the result. Okay, since we are using particle, right, electron is particle. So supposedly we only have two opening, therefore we are going to have two image. Okay, two image on the screen. However, this is not happening. Okay, our expectation is void. The result displayed on the screen is like this. It means that, okay, the electron as particle now exhibit diffraction and interference, okay, producing alternating pattern, bright and dark area. Okay, so means that the electron just now, where previously in classical physics treated as particle, actually can behave as wave. The proof is this one. Okay, that is why we call it wave-particle duality. Next one. So this is the setup of the experiment that going to prove where we have electron beam gun, okay, going to be projected on double slit, alright, and observe the pattern on the screen. The intensity of the pattern will be maximum at the center of the screen, and then will be decreasing to the left and to the right. Okay, the brightness and the intensity is directly proportional to each other. Okay, so the pattern of the electric diffraction, if you use, okay, this is a variation of depending on the number of the electrons used in the experiment. If you only have 100 electrons more or less, okay, you will have a bit scattered pattern, not clearly observe the fringes. If you have 3,000 electrons, then it's going to be more accumulated, more intense, the image of it. Then if you have 70,000 electrons, then it is clear that you have fringes. Okay, the more the better the result is. MashaAllah, how great Allah is. Okay, previously, okay, we know in classical physics, for particle, it is known that the energy consists within a particle E is equivalent to mc squared. Even though this one is not in your syllabus, in general, I can state this. Okay, and then due to some phenomenon that cannot be explained by using this theory, now, okay, we have another idea based on quantum physics, where we say that light is actually a photon. Okay, what does that mean by photon? The light is discrete amount of energy, corpuscle, okay, corpuscle container. Okay, so the wave is contained within a discrete amount of energy. So the wave also can behave as particle whenever the condition is fulfilled. So the energy within a wave is depending on the frequency based on Einstein and Planck constant or postulation. E within photon is equivalent to HF. So who is right, who is wrong? Actually, both of these correct. It's just that the phenomenon, we call it wave-particle duality, only one behavior can be observed at any instance. Okay, and some of the behavior cannot be observed by our naked eyes. Okay, what is the benefit of this theory? This is on how the lights can travel from the sun to us. Okay, where the EM wave can propagate itself by no medium needed, right? Because of this theory. Okay, so the benefit of the sun is great. Without the sun, the earth going to be dying. That's all from me. Thank you very much for your time. Don't forget to do tutorial 10, question number 10, 12, 13, 14, 30, 31, 45, 51 and 52. Please do not hesitate to contact me if you have any question regarding the lecture. Assalamualaikum warahmatullahi wabarakatuh.